Hello and welcome back. Today we will be talking about the normal distribution, something you see very commonly in a statistics course. Okay. A normal distribution is a continuous bell-shaped distribution, also known as the bell curve, that is symmetric about its mean. Many natural phenomena, such as standardized test scores, are approximately normally distributed. Okay. So here are the key characteristics of the normal distribution. When you see it, it's going to look something like this. And we call it the bell curve because you can see it obviously looks like a bell. Um, you know, I'm sure you're familiar with like you see the toy everywhere. I don't know if it's as popular these days, but it's a little toy that has a bunch of dots in it, like, and they're like off by a little bit like this. And you drop a ball down, and the first ball might go down this path, second ball might go down this path. Hopefully you know what I'm talking about. I don't sound crazy, but anywho, if you were to drop 1,000 balls down that little toy, as the balls build up on the bottom, the shape they'll make will look something like this. Here we have it labeled where the center is our mean. And then you could see I wrote here mean plus, this is a lowercase sigma. I was looking up the name of this thing the other day too. It's a lowercase sigma, but this is the mean plus lowercase sigma. Sigma represents our standard deviation. So this is mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation. And then on the left side, mean minus 1 standard deviation, mean minus 2 standard deviation, and mean minus 3 standard deviation. Okay. So characteristics, it's bell-shaped and symmetric. The mean equals the median equals the mode in a perfect world. Half the observations lie on each side of the mean. So 50% of observations over here, 50% of observations will be over there. The tails extend indefinitely without touching the horizontal axes. And the total area under this equals 1 or 100%. Okay. All right. Let's talk about mean and standard deviation. The mean determines the center of the distribution. So again, this is our mean at the center here. The standard deviation determines how spread out the distribution is. If you have not watched my videos on standard deviation, I have 3 out. I would highly recommend checking out, at the very least, the conceptual one, maybe the conceptual and the population. But our standard deviation, just quickly, is the typical distance any given value is from the mean. It's the average value distances are from the mean. Okay. Larger standard deviations produce wider, flatter curves, and a smaller standard deviation produces narrower, taller curves. So that means if our standard deviation has larger values, this thing, I can't see my hands here, but this thing will be wider and take a shape that looks more like this. That's a larger standard deviation. A smaller standard deviation will have it short, peak, short. That would be an example of a smaller standard deviation. Okay. All right, the empirical rule. I'm going to dedicate an entire video to the empirical rule, but it's good to introduce here. For approximately normal distribution, 68% of observations are within plus or minus 1 standard deviation of the mean. Approximately 95% of observations are within plus or minus 2 standard deviations of the mean. And approximately 99.7% of observations are within plus or minus 3 standard deviations of the mean. What does that mean? So going back to our example here, within this window right here, about 68, what is it, or 64? No, but 68. I was right. About 68% of the data will exist in here, in the red there. Then I'll do it again in, let's do yellow. Plus or minus 2 standard deviations. That means within here, about 95% of the data exists there, 95% of observations. And then lastly, for plus or minus 3 standard deviations now in orange, it might be a little bit messy. I don't know how easy it is to see the orange. I'll go both ways with it. Okay. try to include there and there the best I can. But the orange now, 99.7% of all observations exist in there. Okay. Like I said, that's going to get its own video with more detail, but just want to give a quick introduction to that. Okay. All right. Common mistakes when looking at the normal distribution, assuming every bell-shaped graph is perfectly normal. So we could have skew. It could look something like this. That wouldn't be perfectly normal. Confusing the mean with the median in skewed distributions. There we go. For skewed distributions, we use the median. I discussed this in a previous video as well. Believing every data set follows the empirical rule. We're also going to discuss another rule, Chebyshev, some Russian guy. I'll get the name right in that video, but there's another rule that we're going to discuss. And lastly, forgetting that the rule is only an approximation for distributions that are approximately normal. Again, the empirical rule is an approximation about that much that exists. In a perfect world, it would always fit that, but it would always fit that 68, 95, 99.7% rule. But we don't live in a perfect world. Things happen. All right. Normal versus standard normal distributions. The standard normal distribution will be covered in my next video, but here's a little introduction to it. A normal distribution could have any mean and any positive standard deviation. So you could see, for example, here, we just call it the mean, but the mean's given a certain value. So a data set could have a mean of 70. So this would be 70 here, and the standard deviation of 10. So say in some other data set, we have the mean equals 70 and the standard deviation equals 10. Okay, then for our example, that would look like this. 70, 80, 90, 100, and then we go down 60, 50, 40. The mean is 70 and the standard deviation is 10, so that means we go up 10, up 10, up 10, and likewise down 10, down 10, down 10. All right. So this is what we would do for a regular normal distribution. Let's erase this here. So for the standard normal distribution, it's a little bit different, which again, there's more detail in the next video, but a standard normal distribution is a special normal distribution with a mean of 0 and a standard deviation of 1. So standard normal distribution would look like this. 0, 1, 2, 3, -1, -2, -3. So your basic normal distribution can have any values in this bottom part here. It can be different depending on the data, but for a standard normal distribution, we generalize it so it's always 0, 1, 2, 3. And there's a reason for that, which will be discussed later. But again, this is just more of an introduction. Okay, and just a quick wrap up. Normal distribution is one of the most important models in statistics. Understanding its shape and properties prepare students for z-scores, probability, percentiles, and confidence intervals. We'll have more practice problems with the normal distribution when we get to z-scores and maybe in the next video too. But this is more just a conceptual, just kind of introducing what normal distribution looks like and what we could do with it going forward. But that's everything I have for you on the subject of normal distribution. Thank you for tuning in. As always, a link to the notes will be in the video description, and I will see y'all next time. Take care.